Welcome to this video. We are going to learn about energy and three main types: kinetic energy, gravitational potential energy, and elastic potential energy. And then we'll see that no matter what form or type of energy, all energy is simply the ability to do work. First up is kinetic energy. Here's what kinetic energy is conceptually. Objects that are moving, objects that have a speed, have kinetic energy. Here's our mathematical definition, and this is the equation we use when solving problems. An object's kinetic energy is equal to 1/2 times its mass times its speed squared. In this equation, only the speed is squared. Something crucial that we have to be able to recognize when solving problems is this. If an object has a speed v, then it has kinetic energy. Next up is gravitational potential energy. Here's what it is conceptually. It's the energy that an object has because the object is elevated in the presence of gravity. Here's our mathematical definition, which coheres with the concept. Gravitational potential energy is equal to an object's mass times g, the strength of gravity, times the height of the object. Something interesting is that height is always measured from a reference line, or what we call a zero level. Let me demonstrate that. Imagine you're standing on the floor and you're holding a ball 1 meter up. The mass of the ball is 2 kilograms. You might think, this is easy, I can calculate the gravitational potential energy. I just multiply the mass, which is 2, times g, which is 9.8, times the height, which is 1, and you get 19.6. And we're ignoring units right now. That was pretty easy, right? But consider this. What if the floor you're standing on is the second floor of a house, and actually the ball is 4 meters up from the ground outside? Well, now the potential energy is going to be different. The mass is 2 times g, following this equation, which is 9.8, times the new height, which is 4. And this comes to 78.4, still ignoring units. So, which value is correct? Which height is right? Is it this height, or is it this height? Well, the answer is they're both kind of right. The height has to be measured from some zero level. And so before we can measure height, we must establish what our zero level is. The zero level is just a reference line that we use, and we measure the height up vertically from the zero level. So height is a vertical measurement going up from the zero level. Here's another way to think about the zero level. Any object sitting on the zero level has a height of 0. The important thing to remember for our problem solving is this. If an object has a height above a zero level, then that object has gravitational potential energy. Next up is elastic potential energy. This is the energy that something elastic like a spring or a rubber band has because that object has been compressed or stretched. Mathematically, elastic potential energy is 1/2 times k times x squared. K is the spring constant, or the stiffness, of the spring, or the rubber band, or the other elastic object. X is just how far the object has been compressed or stretched. In our problem solving, we are usually going to be using springs as our elastic objects. So here's a spring. Imagine you take the end of the spring, you grip it with your hand, and you pull it back some distance. Here's where the spring normally sits or rests. That's just the natural resting position of the spring. We have moved this spring, let's say, a distance of 1.0 meters. In that case, x is just 1.0. It's how far we have stretched or compressed the spring. The important thing to remember for our problem solving is that whenever an object has compression or stretching x, it has elastic potential energy. Compression and stretching is the indicator for this type of energy. We said at the beginning that all energy was the ability to do work. Let's test this definition in each of the three cases we've seen. First up is kinetic energy. Is kinetic energy the ability to do work? Let's consider. We have a ball with some mass which is moving at a speed. Is this ball able to do work because of its speed, v? The answer is yes. If we put a block in its path, then the ball will move over, it'll collide with the block because it's moving, and it'll push the block some distance. That means it will exert a force over a distance and it will do work. What about potential energy, gravitational potential energy? An object has potential energy of this type if it's elevated above some zero level by a height. So, does this ball, which has gravitational potential energy, is it able to do work? Well, imagine that we put an inclined plane beneath the ball, and on the plane is a block. The ball will roll down into the block, and it'll push the block with some force over a distance. So the force times the distance will, in fact, result in work being done. So yes, the block was able to do work. Last up is elastic potential energy. Let's take a spring and push it in. We have compressed the spring from where it originally was by some distance x. So this spring right here has elastic potential energy. The question is, does that spring have the ability to do work? Well, if we take a block and we put it against the spring, and then we let the spring go, then it will push the block with some force over a distance. And so yes, the spring will be able to do work. So let's summarize everything we've learned so far. When an object has speed, it possesses a particular type of energy called kinetic energy, and the way we calculate the kinetic energy is from this formula. Whenever an object has a height above a zero level, it has gravitational potential energy, and we can calculate the amount of gravitational potential energy using this formula. Lastly, whenever an object has been compressed or stretched, it has elastic potential energy, and we can calculate the amount of elastic potential energy using this formula. The final thing that we can note is that, just like work, all forms of energy are scalars. So these are all three scalars. And just like work, all energy is measured in joules.